couple of you have reached out to me asking for some extra help with the geometric sequences extension worksheet. So I'm going to go over 2 problems from that worksheet and point out a couple things that could be causing you some trouble as you're trying to work them out. So what's happening in these problems are you're given 2 random terms of a geometric sequence. And we know that to write the formula for a geometric sequence, our formula is a sub n is equal to a sub 1 times r to the n minus 1. Now, as we're building up our terms, what's happening is each time we generate a new term, we're really just taking the previous term and multiplying it by another value of r. So we can actually rewrite any term in terms of another term multiplied by r to some power by thinking about how many times would we have to continue multiplying by r to get there. So for example, if I wanted to generate term 4, I could take my first term, a sub 1, and multiply it by r 3 times to generate the next couple terms. So as I'm building this, instead of always working out the formula for a sub n is equal to a sub 1 times r to the n minus 1, I can write a formula relating any 2 terms by taking the one with the larger term number, so in this case a sub 4, and rewriting it as the other term that I have. So for this problem, it's a sub 1, and multiplying it by r raised to the difference between those term numbers. So if I'm at term 4 and this one's at term 1, 4 minus 1 would be 3. So it would take me 3 jumps to get from term 1 up to term 4. Now that I have this rule relating them, I can go ahead and drop the values that I have in here. So a sub 4 is negative 32. A sub 1 is negative 4, and we're going to use this now to help us solve for r. So what I want to do is isolate that r by itself, so I'm going to divide both sides by negative 4, and that's going to give me 8 is equal to r cubed. And what we want is we want to get this r to the first power. So what we're going to do is we're going to raise both sides of our equation to the reciprocal of the power on our r. So if this is r to the 3rd power, I'm going to raise it to the 1/3 power to clear that out. And then to keep my equation balanced, I'm going to raise 8 to that 1/3 power. Now, the problem that some of you might be having is how you enter that into your calculator. So r is equal to 8 to whatever 8 to the 1/3 power is. And if you're entering that on your calculator, you want to make sure that you're using the calculator so that it's going to follow order of operations. So if I want to raise 8 to the 1/3 power, I'm going to type 8, go to my exponent up there. And for this calculator, I can just go ahead and type it as 8 to the 1/3 because it automatically generated that value up there as an exponent. If you do not have a calculator that jumps up to the exponent spot for you, what you actually have to do is use your up arrow key, but then put parentheses around that 1/3. Because a calculator that doesn't have this option where it's going to pop it up as an exponent is going to follow order of operations. And so if my order of operations say 8 to the 1/3, and I don't use parentheses around that 1/3, my calculator is going to read it as 8 to the 1st, which would be just 8, and then take that and divide it by 3. And if you're getting 2.666667 on your screen as your answer for that, that's your problem. So you want to make sure when you're putting it in your calculator that you're actually using parentheses around that. And then if you do that correctly, you'll find out that r is 2. So the question asks you to do 2 things. It asks you to write the explicit formula and also find the 8th term. So now that I know what my r is, I'm going to go ahead and use this formula to write my explicit formula, and then I'll be able to generate my 8th term. So a sub n is equal to a sub 1. And we were lucky, they told me a sub 1 was negative 4 times r, and in this problem r we just solved and found it was 2, raised to the n minus 1. So this right here is my explicit formula. And then I can go ahead and use it to find any term, but for this worksheet they wanted the 8th term. So I'm going to replace n with 8. I'm going to get negative 4 times 2 to the 8 minus 1 or negative 4 times 2 to the 7th power. And if I use my calculator, we get our value for that to be negative 512. All right. Now this problem wasn't so bad because we knew a sub 1. So we were able to jump from R to our explicit formula pretty quickly. When we don't get that lucky, what we're going to have to do is not only solve for R, but then we're also going to have to solve for a sub 1 before we can actually get to this step. Okay, so let's review the process and let's look at how we would solve when we don't know a sub 1 as we look at, this is problem 5 on that worksheet. So we're given the 6th term and the 3rd term. So I'm going to start by saying that a sub 6 is equal to the term they gave me, a sub 3, multiplied by R, and I'm going to raise it to the exponent that's the difference between these, because that's how many steps I would have to take to go from the 3rd term to the 6th term. So 6 minus 3 is going to give me 3. Once I have that rule, I'm going to go ahead and replace a sub 6 with 729, a sub 3 with 27, and we're going to have R cubed. Again, I'm going to divide both sides by 27. So when I take 729 and divide it by 27, it works out to be 27. We get 27 is equal to R to the 3rd. Now you could either think this through and try to figure out what number raised to the 3rd power would equal 27. And if you can use mental math to figure that out, great. Otherwise, again, you're going to raise both sides of your equation to the reciprocal of the exponent on R. So my exponent here was 3, so I'm going to raise this to the 1/3, and I'm going to raise this to the 1/3. That's going to leave me R is equal to 27 raised to the 1/3 power. And again, if you're going to enter this on your calculator and you don't have a calculator with an exponent key, like mine did, you're going to put 27, hit that up arrow for the exponent, and then in parentheses put that 1/3 so that your calculator will know that the 1/3 was the entire exponent there. If you do that, you'll find out R is 3. So now I know that R is 3, so I can start trying to build my formula where we use a sub 1 times R to the n minus 1. For this problem right here, I'm going to choose one of these random 2. It doesn't matter which one you pick. So let's say we choose the smaller value here. All right. So a sub 3, which would be 27, would equal a sub 1 times our R, which we just found out over here was 3, raised to the n minus 1. And since we picked this term right here, this was my 3rd term, so n would be 3. This would be a sub 1 times 3. 3 minus 1 would give me 2 up there for my exponent. Now I'm going to evaluate this. 3 squared is just 9. So we get 27 is equal to a sub 1 times 9. Divide both sides by 9, and I'm going to find a sub 1 is 3. So now I can finally say my rule, a sub n is equal to a sub 1 times my R raised to the n minus 1. And using the values we found here, a sub 1 was 3, and my R was 3. And then using the formula to find the 8th term, I would take a sub 8 is equal to 3 times 3 to the 8 minus 1, or 7. And if you use your calculator, 3 times 3 to the 7th is 6,561. Okay, so these are the examples that I wanted to kind of show you. One where you have an a sub 1 term, and there's a couple on your worksheet that are just like that. And then some where you have 2 random terms. So not only do you have to solve for R, but then you also have to solve for a sub 1 before you can write out your rule. And again, if you're using a calculator that does not have an exponent key, make sure you're putting parentheses around those fractions so that the calculator knows that the entire fraction is the exponent and it doesn't evaluate it using order of operations and just raising it to the 1st power and then dividing it by your denominator. Okay, if you're still having any problems, just feel free to reach out to me.